Hi, I'm Mr. Hamilton, and I've been teaching math for over 15 years. This video is all about the properties of exponential functions, specifically this function in front of us. We're going to answer all those parts and sketch the graph at the end. This question asks, for the function f of x equals negative 3 times 2 to the power of 2x plus 4 plus 1, determine the following showing all steps. Now the first thing is the parent function. Well, that's pretty easy to identify because you just identify what the b value is, what that base is. In this case, it's 2, so the parent function is f of x equals 2 to the power of x. For the y-intercept, we let the x value be 0. We just substitute 0 in and we solve the equation when that's the case. So negative 3 times 2 to the power of 2 times 0 plus 4, all plus 1. Now, a lot of people assume it's just going to give an answer of 1, but follow the math, make sure you're actually getting this, because even though it's 2 times 0, you still have the 4 as the exponent on the 2. So that gives you negative 48 plus 1, which is nowhere near 1, as you can see. This is negative 47, not 1. So be careful assuming that it's just going to be 1. Yes, the asymptote is going to be at 1, as we'll do now, but it doesn't mean that the y-intercept will be. So y equals 2 to the x. That's our base function, or our parent function. And we would just say that has an asymptote at y equals 0. It literally goes down to 0 for that. But if it has an asymptote now up at 1, it's been shifted up 1, then that means that's our new asymptote. That's all we have to look at, just that c value that shifts it up or down at the end. And so y equals 1 is the asymptote. Part D says what the domain and range are. And so for any type of exponential function, the domain is always all the possible x values. So x is a set of all real numbers. The range, though, is something we have to think a little bit about. So if it was y equals 2 to the power of x, then our range would be y is greater than 0. If it was negative, as we can see the a value, the leading value is negative, that's going to flip it over the x-axis and make it go down. So it would be below 0. But because the asymptote has been shifted up to 1, it's going to be below 1. And so there we say y is a set of all real numbers such that y is less than 1. Doesn't touch 1, it's less than 1. Now part E says sketch the graph. And there's a couple of ways we can go about doing that. The first thing I want to discuss is just how do you do that with transformations. So remember that the general form of an exponential function is f of x equals a times b to the power of k bracket x minus d. We common factor out the k value so we clearly see where the d value is properly, plus c. And so I'm just going to rewrite that equation I had at the top with that k value factored out so that we can see that the d value is not 4 or negative 4. It's actually negative 2 here, as we'll discuss in a moment. The a value is negative 3, which is a vertical stretch factor of 3. And it also being negative is going to flip it or reflect it over the x-axis. And so we could take any points from the equation y equals 2 to the power of x, and we can apply these transformations through this. So if k value is 2, that's a horizontal compression. And the reason it's a compression is because the factor for the k value is always 1 over the k value. So it's 1 over 2. The d value is going to be negative 2 here because it's x plus 2 means if the general form is x minus d, it's x minus negative 2. That makes it plus, which means it's going to shift it 2 units left. And then the c value is 1, which means it shifts 1 unit up, as we've already discussed with the asymptote. So what you could do is you could take a couple of points. For example, we could take the point 0, 1. That's the point, always the case for any exponential function that hasn't been transformed. And 2, 4. Those are 2 points that are on that original graph of y equals 2 to the power of x. You could then take the y values and multiply them by negative 3, because that's what the a value is doing. Then you could take the x values and multiply them by a half. That's what the k value is doing. And then the d value is also operating on the x value, so you subtract 2 from that x value. And the c value would be adding 1 to the y value you had from before. So in general, what we're doing is we're taking the coordinates x comma y, and to the x coordinate, we're applying 1 over k to it, and then we're going to add d, whatever d is. And to the y coordinate, we're multiplying it by a, and then we're adding c to that. And that's going to give us the final coordinates, and we could translate all those coordinates like that. But I would ask the question, what are the most meaningful points on this graph? What are the things we care the most about? Because it might not be those points that we transform. They might not be much of interest to us. The ones I would argue are the most important are starting with a y-intercept. That's by far the most important. We know that's y equals negative 47, which if you translate 0, 1, and 2, 4, you're not going to get that by translating that. The other key thing we want to look at is the asymptote y being 1. And so because of that, I'm going to go up and down by a scale of 10, and I'm going to go with an x scale by 1. And I'm going to label my asymptote at y equals 1. And so I know that it's coming from below. It's going to go through negative 47. It's going to look something like that. So what I want to do just to get a better sense of the shape is I want to substitute in a couple of x values that are just to the left of that y-intercept. So I'm going to substitute in negative 1. And when I substitute that in, I get 2 to the power of negative 1 plus 4 as the exponent. And so I get 2 as the exponent, which gives me negative 11. And then if I sub in negative 2, I end up getting, after subbing it in, negative 2. So what I can do is I can label those points on my graph. And you can actually see that that's a lot steeper than I would have originally labeled those curves with. So it's going to go up through those key points. It's going to be a very steep graph like shown. And we can label that with the function f of x equals negative 3 times 2 to the power of 2x plus 4, all plus 1. Thanks so much for watching. I hope this was helpful. If you want more on the exponent laws and how to apply them with lots more examples, check out the video on the left. The video on the right is all about those transformations, and it looks at them with a number of other different functions and how to apply those transformations A, K, D, and C. So if you want to see that, check out the video on the right. Thanks so much for watching.